Okay, now we're going to finish the rest of the notes for review of basic sinusoids with vertical transformations. Before watching this video, make sure you've completed the Desmos activity. And there was a previous video that explained how to do the Desmos activity. The Desmos activity is summarized here in number 2. So I'm going to go ahead and go over what you should have concluded from the activity. So letter A says, let A equals 1 and modify the value of D. And then describe what effect the value of D has on the sinusoid and explain how the D value in the equation manifests on the graph. Right? So the D value shifts the graph vertically. So that means makes it move up or down. And the D value tells us, or it is the midline of the graph, right? So if we have some sort of sine function, let's say it's like this. Oh wait, let me do that again. Let's say we have a sine function. Normally our graph of sine x goes like this. So let's say this is y equals sine x, and then I change the graph and I make it y equals sine x, let's say plus 3 or something. Then my graph will shift up 3. So let's say this is y equals sine x plus 3, right? So that's what the D value does. It moves it either up or down depending on what the value for D is. In part B, you were asked to let D equal 0 and then modify the value of A. To see what happens when A is positive or negative, and describe what effect the value of A has on the sinusoid and how it manifests on the graph. So I'm going to summarize a few things that you should have discovered. So the absolute value of A is the amplitude of the graph. And I should explain what the amplitude is. The amplitude is the distance from the midline to the minimum or the midline to the maximum. So the amplitude is the distance from the midline to the maximum, or from the midline to the minimum, or alternatively, or it's 1/2 the maximum minus the minimum. That's another way to think of it. Okay. The absolute value of A is the vertical stretch factor. So if A, let's say, is 3, the graph is stretched vertically by a factor of 3. If A is 1/2, it's shrunk vertically by a factor of 1/2. If A is negative, the graph is reflected over the x-axis. The graph is reflected over its midline, I guess I should say. So for the parent function, it's the x-axis. For other graphs, it would be the midline. All right, and then the last one said, change the equation so that it is a cosine equation instead of a sine equation. Oh, you know what? Before I go on, let me just make a little sketch and explain what the amplitude is. So if we have, let's say, a sine function, something like this, and this was the midline, then the amplitude is the distance from the midline to the maximum. So this distance is the amplitude. So if we have an equation like y equals 3 sine x plus 5, 3 is the amplitude. Okay, letter C said, change the equation so that is a cosine equation instead of a sine equation. What happened? Describe the main difference between a sine and cosine graph without any horizontal shifts. Okay, so we're not changing things left or right. We're only stretching them vertically or shifting them up or down. So I'm going to summarize. We have y equals a cosine x plus d. This graph starts, and that by that I mean the point on the y-axis, at a maximum or minimum point. Okay, it's a maximum if a is greater than 0 and a minimum if a is less than 0. Then in terms of sine, y equals a sine x plus d. That graph starts, so that means on the y-axis, at the midline. And then we want to say the graph will go up as we go to the right when a is greater than 0, and down if a is less than 0. Right, so if I have a sine function that looks like this, since this graph is going down through its midline, this will have a negative a value. Okay, let's flip to the next page. Okay, so here we're asked to graph 4 sinusoids, sine or cosine functions that have some vertical stretches and vertical shifts. In order to graph these, I would begin by looking at the equation and see what we can determine. So I have 2 sine x minus 1. This means this 2 here means that the amplitude is equal to 2, and the minus 1 means the graph is shifted down 1, and that means d is equal to negative 1. So the midline has the equation y equals negative 1. It's going to start at the midline, so it's a sine, so it's going to start at midline, and it'll go up because it's a positive a value. So now I'm going to go ahead and put a scale on my graph. So I'm going to let 1 square be 1 unit on the y-axis. And we know that sine normally starts at the midline. So when I graph these, what I do is I will draw in the midline. So I'm going to draw in a line, a dotted line, because it's not really part of the graph, at the midline. So this is the midline. Y equals negative 1. And then the amplitude is 2. So that means the graph goes up 2 and down 2 relative to the midline. So I'm going to go up 2, that will put me at y equals 1, and down 2, which will put me at y equals negative 3. And this creates like a little envelope, and the sine function is going to be bounded inside this envelope. And now we can go ahead and plot some points. So the sine function is going to start at the midline. So it's going to start, meaning on the y-axis, at 0, negative 1. And then I'm going to have key points every quarter period. The period is 2 pi, right? That's how long it took for one cycle. And key points are going to be every pi over 2. So it's going to be at pi over 2, it's going to be going up. I know it's going up because a is positive. And then I'm going to continue with my cycle. I'm going to go another pi over 2. I'll be back at the midline. Another pi over 2 will be at 3 pi over 2. That's at a minimum. Another pi over 2 is the next key point. It'll be at 2 pi negative 1. And we'll also put some points in the negative direction. Just every pi over 2, we're going to go either from the maximum to the midline to the minimum, etc. So I'm going to put on those key points, and now I'm going to go ahead and sketch my graph. I'm going to put arrows on the end, make sure I have rounded turns. Okay, let's try the next one. We've got y, and I encourage you, stop the video, try to plot these on your own, and then come back and watch the video and see if you agree with my solution. Okay, so here we know that the d value, the d is 1, so the midline is at y equals 1. This graph is going up 1 relative to the parent. The amplitude is going to be 3. The amplitude is never negative. So the amplitude is 3, never negative 3. But what does this negative mean? This means it's going to start at a minimum value because this is a reflected cosine. Okay, so it's flipped over its midline. So I'm going to go ahead, just like in the previous graph, I'm going to put a scale on the axes. I'll do 1 square is 1 unit on the y-axis. And now I am going to draw in the midline. So let me dash that in. So the midline was at y equals 1. So I'll put that in. And then I will go, the amplitude is 3. So I'm going to go up 3 units. So that'll put us at y equals 4. And down 3 units, which will be the place where the minimum values are, at y equals negative 2. Now we have this nice envelope to sketch our graph. So let's put some points on. It's cosine, so cosine either starts at a maximum or a minimum, starting meaning at the y-axis. Since this is a negative cosine, it's going to start at a minimum. So I'm going to plot 0, negative 2, then every quarter period. So I'm going to write that down. So key points are every 1 quarter period, and the period here is 2 pi. That's when the unit circle takes 2 pi to go all the way around, so that's every pi over 2. So every pi over 2, we're going to have a new key point. So if we were at a minimum, at pi over 2, we're at the midline. Another pi over 2, we're at a maximum. So at pi, we're at 4. 3 pi over 2, we're back to the midline. 2 pi, we're back to minimum. And now I'm going to go ahead and sketch, put in the other points, and then we can sketch this graph, putting arrows at the end, making nice rounded curves. Make sure that the arrows are going up here. Don't make the arrow coming down beyond the minimum negative 2 on either end of your graph. All right, let's try the next one. So we've got y equals cosine x plus 2. So examining the values for a and d, we see that this plus 2, d equals 2, that means we have a midline at y equals 2. And the value here is really a 1. So a equals 1, which means the amplitude is 1. So we're going to go up 1 and down 1 from the midline. A is positive, so this cosine graph will start at a maximum. When it's a negative a value, it'll start at a minimum. I'm going to put a scale on my graph. I'm going to let 1 square be 1 unit. So let's do that. So 1, 2, 3, negative 1, negative 2. The x-axis is already the scale's already marked for us. And let's go ahead, we'll put on the midline at y equals 2. So I'll dash that in, creating a nice envelope for my sketch. The amplitude is 1, so I'll go up 1 to y equals 3 and down 1 to y equals 1 for my maximum and minimum values. And then this is a cosine. Cosine will start at a maximum or minimum. This one will start at a maximum because it's a positive cosine. So it's going to start at 0, 3. And then key points will be every pi over 2. So we're going to go be at pi over 2. We're going to be at the midline. Pi, we're going to be at the minimum, which is 1. 3 pi over 2 back to the midline, which is at 2. 2 pi back to the maximum, which is at 3. And then continue the pattern in the negative direction, where every pi over 2 units, you get a new key point, which is either at a maximum, midline, or minimum. And then connect the points with a nice smooth curve, and then put arrows on the end, making sure you don't go outside that envelope we created. Okay, the last graph that we're going to do is y is equal to negative 3 sine x minus 1. So here we can see that, I'll write it down here, d is equal to negative 1. So the midline is going to be at y equals negative 1. And the amplitude is the absolute value of negative 3. So the amplitude is 3. So we're going to go up 3 and down 3. But because we have a negative, I'm going to say this is a reflected sine graph. So it's going to start, because it's sine, it starts at the midline, but then it will go down, but goes down from left to right. Okay, so let's put on our information. I'm going to let 1 square be 1 unit again. So 1, 2, 3 on the y-axis. And I'm going to go ahead and sketch the midline, which was at y equals negative 1. And then the amplitude is 3, so I'm going to go up 3 units. So that'll put me at y equals 2. So I'll put this in y equals negative 1, y equals 2, and down 3 units. So the minimum values are going to be at y equals negative 4. And then it's sine. So sine starts, meaning at the y-axis, at the midline. So we have a point at 0, negative 1. And now it starts going down, right? A normal sine function would be going up from left to right. But this is reflected, so it's going to be going down from left to right. So we're going to have a point at pi over 2, negative 4. Then at pi, we're back to the midline. 3 pi over 2, we're at the maximum at y equals 2. 2 pi, we're back to the midline. And then let's continue the pattern in the negative direction. And now we will connect these points with a nice smooth curve. Putting arrows on the ends. And that's it. That's our graph of y equals negative 3 sine x minus 1. In example 4, we're going to do this process in reverse. So we're given a graph, and we need to write the equation. So go ahead, stop the video, see if you can do it on your own. And then if you need help, come back and I will guide you through it. And if you don't need help, then just come back, watch the video, and make sure you agree with the equation that I got. So the first thing I do when I face a problem like this is I want to draw in the midline and the maximum and the minimum. That helps me find the key information. So I am going to draw in the midline, which is at y equals negative 2, and the maximum and the minimum. And from this, remember we talked about the amplitude. So the amplitude is the distance from the midline to the maximum, or the midline to the minimum. So here we're going from y equals negative 2. The maximum looks like it's at y equals 1. So the amplitude is 3 units. Next, we want to decide if we want to write this as a sine function or a cosine function. We can always write it as either, but one will often be easier. How do we know which one to write it as? I'm going to look at on the y-axis. On the y-axis, this function is passing through a maximum. So this will be easier to write as a cosine. So I'm going to write that down because it starts, so on the y-axis, that's what we mean, at a maximum value. So we're going to write it as cosine. And the other thing we need to know is the vertical shift. So y equals negative 2, that means d equals negative 2, our midline. Sorry, I should say the midline is at y equals negative 2. That means d is negative 2. So now we are ready to write our function. We know that the value for a is going to be positive because it starts at a maximum. So a is going to be positive. So we can write our equation, and we have y equals the amplitude, which is 3. We want it to be positive because it starts at a maximum. Cosine x, and then the d is minus 2 because it's shifted down 2. Okay, let's take a look at the next graph. So I'm going to once again sketch in the midline. So the midline appears to be at y equals -3. The maximum is at y equals, oops, the maximum is at y equals -1. And the minimum is at y equals -5. So the amplitude is the distance from the midline to the maximum or the midline to the minimum. So the amplitude here is the distance from -3 to -1. So the amplitude is 2 units. The midline is at y equals -3, which means D is -3. And now we have to decide, do we want to write this as a sine function or a cosine function? So let's look at where it starts. So on the y-axis, it's passing through the midline. Okay, so I'm going to jot that down. Passes through midline at y-axis. So this is kind of where it starts. And that means it'll be easier to write a sine. So it'll be easier to write a sine function for this graph. And the graph is passing, it's going downward as we go from left to right, which means this is a reflected sine function. So the a value is going to be negative. So a is negative. And now we are ready to put this all together to write the equation. So we can write y equals negative, because it's going downwards through that starting point. The amplitude is 2 sine of x, and then it's shifted down 3. Okay, the last problem. We are asked to write the equation for a sinusoid, that means a sine or cosine, that has a minimum at 0, -5, and a maximum at pi 9. So I would go ahead and make a sketch. So we have a minimum at 0, -5, and a maximum at pi 9. So this is pi 9. So the midline is halfway between the maximum and minimum. So halfway between -5 and 9. So that's a total of 14 units. So it'll be 7 units away. So 9 minus 7 is 2. So the midline is going to be at y equals 2. That's also the amplitude. So the amplitude is half the distance between the minimum and the maximum. So the amplitude is 7. And then this is probably enough to sketch this graph. My graph isn't really to scale. Maybe I should let me go ahead and move the -5 up a little bit so that this graph looks a little bit better. So let's say this is 0, -5. That looks a little bit better. So our graph is going to look something like that. And which equation will be better for us to write? Since this starts at a minimum, it's going to be easier to write as a cosine. And it's actually going to be a negative cosine because it starts at a minimum. And what else do we know? We know the amplitude. We know the midline. So the midline is y equals -2. That means D is -2. So let's put it together. So y is equal to -7 cosine of x. And then D is +2. Oh, I wrote that wrong. D is +2, +2.